Okay, now let's talk about what's called a discrete general distribution. This is the most basic type of distribution. So let's have a look at it in terms of, in this case, our number of walk-ups. So let's say the airline allows people to walk up. If you remember here, kind of in the intro, there were, in the setup here, they accept reservations up to 24 hours in advance. Beyond that, people have to kind of go standby, if you will, or walk up on the day of and see if they get a spot. So this number of walk-ups is going to follow a discrete general distribution. That really just means that we know 30% of the time nobody comes up, or there's no walk-ups. 45% of the time there's one walk-up. 25% of the time we have two people show up on the day of looking for seats. Okay, so how we model that, we really just put it into a little table here like this. And we do the following. We're going to use what's called a lookup call, and we're going to get these lower limits right here. Okay, so here we are. Here's what we're going to do. We're going to make this table here, a walk-up distribution. We're going to make, on the table, we're going to put in our values. So these numbers here of walk-ups, 0, 1, or 2, their associated probabilities. So the 0.3, 0.45, and 0.25 are the probabilities we were given. So again, we would be given these, or you would collect them based off of past data. You'd look how many times you have each of these scenarios happening. And then finally, you make these lower limits. And these lower limits you get by doing the following. Start at 0. Okay. And then take that 0 and add the first probability to it. Oops, sorry, that should be a plus there. Okay. And then copy that down. Okay, so we just copy that down now, and if you'll notice, it actually keeps adding up the probabilities. This is actually a cumulative probability. Start at 0, 0 plus the 30 gives us 30, 0.3, the 30 plus the 45% gives us 75. And then if you want, you don't have to do this. On the other side, just take the lower limit for the next category as your upper limit. Okay, and so again, we're going to see the 30 here is going to be the upper limit here. And this gives you a range that you're going to look between, okay, when you generate a random number. So we're going to use the lookup call, okay, on a random number. Now every time we hit rand, we're going to get like something between 0 and 1. So let's say we got, let's just run it, equals rand. Let's see what we get. So we get 0.44. What we do with that, we go look for that number in these intervals. And we go, okay, 0.44 is in here. What we want to do then is we want to go and grab 1. What the heck are we doing that for? So that's what this lookup's going to do. It's going to look for that random number in these intervals, basically. Why are we doing that? What that's going to recreate, it's going to give us 0 30% of the time, because the width of this interval is going to be 30%, which is these odds. So 30% of the time our random number will land in this interval, so it'll give us a 0 30% of the time. Okay, and again, that's going to make those intervals that equal to the width, where their width, is the probability of each of these numbers happening. So there's going to be a 30% chance we get 0, because when we use rand and we grab a probability, it's going to 30% of the time give us a number in this range. And again, that lookup is going to go look for that random number in these ranges. When it finds the range it lands in, example 0.44, it would be in here. It's going to return that number. So let's go do that now. So let's go run that number of walk-ups. It's going to be lookup on the random number, and we're going to look for it in these lower limits. Use your lower limits. Again, use those lower limits, and return these numbers of walk-ups. So it'll return either a 0, a 1, or a 2. And of course, every time we hit enter, we might get a different result.